All right, in this video, we're going to take a look at increasing and decreasing intervals for the properties of a function. And there's other videos out there for all the other properties if you need. So increasing represents when, as we move from left to right, so in other words, as x increases, the value of the dependent variable, or y, will increase. So our graph's going to be going up. For decreasing, same idea. When we move it from left to right again, still as x increases, the value of the dependent variable, or y, decreases. So we're going to be going down. Let's take a look at increasing first, and we'll take a look at a couple examples. So take a look at this function. We're going to go from left to right. Where does it start? It starts right here at 1, and then it increases, 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 and it stops increasing at 4. 1, 2, 3, 4. And so now we just need to write in our interval, and we write f for function f, a little up arrow, which represents as increasing, and then the word over, which just is indicated for over the interval. Our lowest value when it starts increasing, which is 1, when it stops increasing, which is 4, and then square brackets to show that it's an interval as opposed to round brackets, which we'd use for a coordinate. Look at another example. All right, let's take a look at this one. When does it start increasing? Well, it's actually never increasing. It starts at -1, and then it's always going down, going down. So in this case, we just say that it's never increasing. That's easy enough. A bit of an exception there. Let's take a look at a third example. All right, remember, since it continues off, we could put arrows here indicating that it keeps going on and on. So when does this one start increasing? Well, it's coming down, 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 and actually right there is where it starts going up again. So that's where x equals 1, and it's going up, 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 all the way to 3 to 4. And since it continues off, that means it's going to always be increasing after that. It's never going to start coming down again. That's what the arrow means. So to write it out, we're going to put f is increasing over the interval, square bracket. Our lowest value when it starts increasing is at 1. And this one, it never stops increasing. So we can put infinity. And since it can't equal infinity, we put the open bracket there. Let's take a look at one more example here. All right, so here's a little bit more complicated because we got our lines going up and down. Where does it start increasing? All right, right here, when x is 0, is where it starts increasing. It's increasing, 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 increasing. Oh, and it stops increasing right at this point here when x is 10, 20, 30. So if we go to write it, f is increasing over, and put in our square brackets. The lowest value of x is 0. Highest value of x is 30. And we close that off. Now, we take a look. It starts going down, but then it actually has another place where it's increasing. It's increasing again here. So we're going to have to put in that second interval as well. And to do that, we start by putting in a u. And the U stands for union, but it basically just means and. So it's basically saying it's increasing over this interval and over another interval. Well, what's our value here where it starts increasing again? 30, 40, 50. So it's increasing again between 50. And when does it stop increasing? 60, 70, 80, right there when it ends. And then we close our bracket there. So again, here we put the f functions increasing over one interval, and then the union to show that it's increasing at another time as well, and then we put in the second interval. And if we had 3 or 4 times, we could put several unions in the middle and keep stringing them along. Now let's take a look at decreasing. So same idea as for decreasing, except here we're looking at the value of y going down. So it's coming down. And so we take a look here. Where does it start decreasing? Well, it starts decreasing right at the beginning. In this case, when x is -1. So f for a function, rather than an up arrow, makes sense, put a down arrow, over, starts increasing at -1. I'll write that in. And it's decreasing, decreasing, decreasing. And again, since it goes off here, that means it's going to keep going down, 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 down. So it'll never stop decreasing, so we can put infinity, and then our open bracket because it can never equal infinity. Our next example. All right, when is this one decreasing? This one's never decreasing. This one's always going up. So we can just write that it's never decreasing. Piece of cake. Next one. All right, well this one, again, we'll put our arrows here. We notice it starts, it's coming down. And again, since this is an arrow, it would continue off. So in this case, f is decreasing over, first interval is negative infinity. It starts going down at negative infinity. In other words, it's going down, 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 down. And it stops going down right here when x is 1. Just put it in like that. And look at our last example. It's increasing, increasing. Starts going down right here where x is 30. And then it stops going down right here when x is 50. So f is decreasing over put an interval 30, comma 50. And then what you'll notice is that the values for increasing seem to fit quite well with the values for decreasing. In other words, down here, it's increasing until it starts decreasing, and then it's decreasing until it starts increasing again. Of course, that makes sense. So there you go. There's increasing and decreasing. You can check out the other videos for the other properties of a function.